Okay, this week we're moving on to our geometry units. And in geometry, the main thing we're looking at this week is called hierarchies. And we're focusing on hierarchies of triangles and of quadrilaterals. So I'm going to give you an example first of the hierarchy of a triangle. So the very beginning, the category is polygons. So we start up here with polygons. That's our category. And then you can see we have our subcategory 1, which is characterized by the number of sides. So we have triangles that has 3 sides, quadrilaterals that have 4 sides, pentagons that have 5 sides, and hexagons that have 6 sides. So our subcategory 1 separates the polygons by their number of sides. Then we're going to be focusing on triangles now. So we're going to be focusing on the subcategories of triangles. So the subcategory of triangles is then categorized by their side length. So we have an equilateral triangle where all sides are congruent. We have an isosceles triangle where 2 sides are congruent. And then we have a scalene triangle where no sides are congruent. Okay? And then our subcategory 3 under triangles is categorized by angle size, which it's not on here, but an equilateral triangle, their subcategory 3 of angle sides would be acute. So it would be an acute equilateral triangle, because all of the angles would be acute. Under the isosceles triangle, we have obtuse isosceles triangles, which means that 2 sides are congruent and they have 1 obtuse angle. An acute isosceles triangle is 2 sides are congruent and they have 3 acute angles. A right isosceles triangle means that 2 sides are congruent and they have 1 right angle. Then we come back up to our subcategory 2 for a scalene triangle, and a scalene triangle has 3 subcategories of angle size as well. It has the obtuse scalene triangle, which means no sides are congruent, and it has 1 obtuse angle. Then there's the acute scalene triangle, which means that no sides are congruent, and it has 3 acute angles. And then we have the right scalene triangle, which means no sides are congruent, but it has 1 right angle. So that's showing you the different hierarchies. And the way we work with this is that you can have, so we have a polygon, and then you can go to triangle, and then the 3 different types of triangles. And underneath 3 different types of triangles, you can then classify them by their angle sizes. Okay? So another one that we look at besides triangles that we spend a lot of time on is quadrilaterals. So let me switch this up, get this set up for you to see. Okay, so this is our hierarchy of quadrilaterals, which we'll be spending a few days on. So the first thing we do is we look at a quadrilateral. So a quadrilateral is any polygon with 4 sides. And then we look at our subcategories of quadrilaterals. So underneath the quadrilaterals, we have a trapezoid, a parallelogram, and a kite. So a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. A parallelogram is a quadrilateral with 2 pairs of parallel sides opposite each other. And then a kite is a quadrilateral with 2 pairs of adjacent sides that are congruent. And so this is our subcategory 1. So now we're going to subcategory 2, where we find rectangles and rhombuses. So we come down from the parallelogram. So a rectangle is a parallelogram with 4 right angles. So then we come up to the rhombus. The rhombus falls under a parallelogram and a kite, because it can be a parallelogram or a kite with 4 congruent sides. And then we come down to our subcategory 3, which is a square. And you can see the rectangle and the rhombus both come down here to connect to the square. So a square is a parallelogram or kite with 4 right angles or 4 congruent sides is a square. And we're doing the hierarchy. We talk about how the hierarchy works, that you can move this way on the hierarchy. So you can say all squares are rectangles, because all squares have 4 right angles, so all squares are rectangles. And you can say all rectangles are parallelograms, because they're just a parallelogram with 4 right angles. So every rectangle is a parallelogram, and every parallelogram is a quadrilateral. So we talk about on the hierarchy how we can move up and follow the lineage of it all the way up. So all squares then are parallelograms, and they're also quadrilaterals. An example, again, would be that of rhombus. So all rhombuses are kites, and all rhombuses are parallelograms. Okay? And then we talk about how it works going up, but how it doesn't work in the opposite direction. So if you're going this way, you cannot say that all parallelograms are rectangles, because a parallelogram does not need to have 4 right angles. So the lineage doesn't work going this way. You can't say all parallelograms are rectangles, because that's not accurate, because not all parallelograms have 4 right angles. But again, if you're moving this way, it does work, because all rectangles have 2 pairs of parallel sides that are opposite each other, so all rectangles are parallelograms. So again, we spend a lot of time exploring quadrilaterals and figuring out that, oh, so a square is always a rectangle, a square can always be a rhombus, and a square can always then be a parallelogram. So again, we talk about how we can move up to trace the lineage of the different quadrilaterals.